Welcome to 2019 higher level, question B1. This is a Conics question with links to orthographic projection. So the image on the right shows the Lacey Bridge in Drogheda, County Louth. The projections of the bridge are shown here below. Okay. The curve ABC is a parabola in elevation with vertex B. Draw the given elevation. Okay, so let's start with that. Okay. All our measurements are given in meters, and we've got scale 1 to 100, so we can convert all of those. And to do them quickly, I'm just going to work out that 8.1 meters is going to be 81 millimeters. Okay, so I'm just basically moving the decimal point for all of those. So the height, actually, just to start off, we want a rectangle to go around the parabola ABC. So the length is going to be 252 and the height is going to be 81. So XY line. Two, 5, 2. Okay, and a height of 81. And halfway along that then, 252 is going to be, I'll just bisect it to make life a little bit easier and quicker and more accurate. And that will locate my vertex. So we've got A, B, C. Okay, so looking at this, they've already divided up for these vertical positions 1, 2, 3, 4, 5, 6, 7. They divide up into 7 equal parts. Okay, so that'll make life a little bit easier for me that I'm not going to have to divide up one side. So I'll just measure 80, 36, 18, 18. Let's do that here. Our vertical numbers will be there. Okay, now just divide this side part up into 7 equal parts. Step off 7 times. Drawing back to A. And drawing them back up to B then. let's find its points. 2, 3, 4, 6. Okay, so here's my parabola. Okay, now I could do the same thing all over here again, but quicker method is to use axial symmetry, so mirror everything across, and that will actually also locate my members there if I don't need to measure 18 all the way across there too. So let's use our axial symmetry. I can draw my parabola running up this way also. And heavying my vertical parts. That's like a little time saver there. In the elevation, just the axial symmetry. Shows with two things like that. The more we practice them, the more we will identify them. So that's my elevation. You can take that off. So the curves DEF and PQS are in plan are branches of a double hyperbola. So DEF and PQS, there are double hyperbola. Okay, the vertices the vertices are E and Q. So here are vertices. Construction for the portion DE of one branch is shown. So they are telling us how to get the points there on our parabola. So that's kind of a great little kind of clue to us. The construction for portion DE, was also shown. HLG is a straight line, so HLG, that's a straight line, and draw the given plane. So HLG is a straight line. The reason they're telling us that is it turns into a curve with a center there. That's our radius. So that's and a 90-degree angle there. So they are all tangents to that arc. Okay, so H as far as G is a tangent, and so is going to be this line, this line, this line. Okay, so we'll start with our center line, and we can work back from there. Probably draw our hyperbola to begin with, or a double hyperbola. So I'm going to come down. That'll be fine. Start with the center line to begin with. Okay, and measurements they've given us. Okay, so 4 meters, so 40, 90. So 40. 90. Should fall down as well. that's D, E, F. Okay. Let's say there. I need to draw a little box here that contains them. Okay, now we can see there lines running back to E from the side of that box, and from this side of that box running to Q. So those divisions are the ones that we'll use, and we'll have to divide that line up in a while. Now we 1, 2, 3, 4, 5. We'll be able to mark them off actually. So first of all, project these down. They're actually in line with each other. So project down our vertical members. So that's our divisions. Okay, and we're joining them all back to E. Okay, like I said, we have equal divisions here, so there's 5 equal parts, 5 into 40 millimeters, so we're going to go in eighths, 8, 16, 24, 32. And they all now join back to Q, so we need to find Q. So 36 and 36. Put that down middle, it should be 36, which it is. Measure out 36 again. So that's my Q. Join all of them back. Find our points then. So you can see here, this line crossing this line here, there point 1, point 1, 2, point 3, point 4, back to D. Okay, so let me draw that. Okay, and looking here in our question, we've got our center line, another center line here, so I can actually mirror down, mirror across. So let's mirror downward. Compass. Okay, and mirror all those across this way. Okay, so our time saver here is this point and this point are the same length, so you can swing an arc for both of those at the same time. Like I said earlier, we're always looking for little ways to save time. Okay, so that's our branches of our hyperbola done. Okay, and we're always working in order. Construction of one branch, so it's shown, and then we got a straight line running from H to G. So here is G. Need to mark off our road. So we're going through, so that's going to be G. So for the position of H, we don't have that distance, but we do know that G goes through L, and that's a point we do have on that rectangle that we've drawn. So here is point L. So we can extend from G through there to find H. So I can actually do that on here and find a point which they haven't actually given us. We can mirror those down also, so the distance from center to H the same there and the same there. And I can also find its corresponding distance right there. I'll draw in those other two sides in a moment, but I'm just going to jump on and find this curve. So I know the curve is down through the center and at 90 degrees to these tangential lines as I mentioned. So let's do sliding set squares. That's my center there, and actually mirror that through as well. It's going to be the same on both sides. So all time savers again. Let's draw our curve. Established here. Should be same as that. I need to actually find where that ends, so bring that distance across. That will allow me now to draw the other tangents. Okay, so this now is the roadway. So I have the position of the roadway here at G and also in that point that we just used. So heavy line. Dashed here again, and heavy line. Same up with G. Let's finish off those edges heavy. Outermost points. Okay. I think that is everything in plan completed. Yep. So last one, in elevation, the focus of the parabola ABC is located 4.9 meters from the vertex B. So in the elevation, here's our vertex B. So we need to find a focus in here. Okay, our directrix would be out there somewhere. Well, exactly the same distance out, because the eccentricity of parabola is 1. Locate the focus and draw a line which is tangential to the parabola at point C. Okay, so let's locate the focus first. It's going to be 49 from B. I'm just using this part of my set square to measure it, because my kind of 0 was gone a bit faded there, but that's 49 mil I'm measuring there to find my focus. And then for a parabola, okay, PF over PD is equal to 1. So what I'm going to do is join my focus to my point C. My directrix will be out there, so what I'm going to do is bisect that angle. So swing an arc, so swing 2 arcs the same length, radius, and draw my tangent then in that position. So that's my focus, joined it back, bisect that second that angle, and that found my tangent there. Okay, so that's the solution there to B2 in 2019.